Hi guys, this is Ashish from Edureka, and today I'm going to talk about HDFS or Hadoop Distributed File System. Fundamentally, you can break down Hadoop framework into two parts, that is HDFS for storing the data across a cluster and MapReduce which deals with processing of data stored in HDFS in a parallel fashion. So in a nutshell, HDFS is all about storing and managing huge data sets in, or you can say, across the cluster. Now you'd be thinking, how does HDFS work? First of all, as you know, HDFS stands for Hadoop Distributed File System. So let us take a step back and understand what actually is a distributed file system in the first place. A distributed file system talks about managing data, that is files or folders, across multiple nodes or computers. It serves the same purpose as the file system provided by the OS in your PC. For example, for Windows, you have something called as NTFS, or for Mac, you have something called as HFS. The only difference between the file system that is there in your PC, that is your local file system, and a distributed file system is that instead of storing data in a single machine, in case of distributed file system, your data is stored in a cluster, which is again nothing but a bunch of computers connected to each other forming a network. Even though the files are stored across a cluster, the DFS will organize and display your data in such a manner that if you try to access the data from any one of the machine in the cluster, you will feel as if the data is stored in the machine that you were using. In other words, DFS provides you an abstraction of a single big machine that has a combined disk capacity equal to sum total of disk capacity of each node in the DFS cluster. Now let me give you an example just to clarify things further. Suppose you have a DFS comprising of 4 computers where each computer has a disk capacity of 1 TB. In this case, the DFS will provide you an abstraction of a very big machine that has combined storage of 4 TB. Now you can go ahead and store a single file of, let's say, 3 TB, which will eventually get stored and distributed across the 4 computers. So this is all about DFS, guys. Next, you may ask why we need DFS in the first place. I mean, we could have just increased the disk capacity of single machine to whatever that is required. Well, first thing is there is a limit up to which you can increase the disk capacity of a single machine. Even if you somehow manage to store all of the data on a single machine, it would lead to another big problem. That is, it would take a lot of time to process the data using a single machine. Let us take an example to understand this. For example, let us say I'm having a 4 GB file that takes 4 hours to completely process it using a single PC. Now what I did, I used DFS and stored the same 4 GB file in a 4-node cluster, where each node was storing a chunk of file that will be equal to 1 GB. So therefore, in total, the 4 GB file was distributed across the cluster. Now what I can do, I can process each chunk of file parallelly using the 4 computers, thus reducing the entire processing time, which will be reduced to 1/4 of the former, that is equal to 1 hour. So that is the advantage that you get with DFS. So I guess by now you would have understood what is DFS or why do we need it. Let us come back to HDFS again. So again, HDFS is also a distributed file system, but for Hadoop, that allows you to store huge data sets, that is terabytes and petabytes of data, across the cluster or multiple machines, so that you can go ahead and process the data stored in each machine in parallel. Simple yet quite powerful idea, isn't it? So that is the main reason why Hadoop or HDFS became so famous. Now the next question that would be pondering in your mind is, how does HDFS manages the data? Or who distributes the data across the cluster? How can one access the data present inside HDFS? To answer these questions, you need to understand the architecture of HDFS. Now, HDFS or Hadoop cluster follows master-slave topology. It means that you have one master node and remaining all other nodes are slave nodes. In HDFS, the master node is called as name node, whereas the slave nodes are called as data nodes. Now, data nodes are actually responsible for storing the actual data, whereas name node, being the master node, is responsible for managing all the slave nodes or data nodes. Other responsibility of name node includes maintaining and managing metadata. The metadata is information about data that is there or present inside the data nodes. So name node will be keeping all those information regarding which data are stored in which of the data nodes. Along with that, data node are supposed to send some hard bit or a signal so as to ensure that all the data nodes are working to name node. So if, let's say, one of the data nodes stops sending that signal, the name node will assume that that particular data node has been failed, and that same will be notified to the admin so that a new data node can be permissioned. So other information in the metadata are like file permission, directory permission, the data locations, and all that. So all those stuffs are there in the name node metadata. So now that you have understood the architecture that is followed by HDFS, where we have one master node and we have slave nodes as data nodes. Now the question is how files are actually stored inside HDFS. Just like any file system, in case of HDFS also, the files are stored as blocks. The only difference between the file system block size that is there in your system to that of our HDFS is the default size of each block in HDFS is 128 MB, since we are dealing with a large or huge amount of data set. It is configurable and you can go ahead and change the default block size as per your use case. Now let us understand how does this work. For example, let's say I want to put a file of 380 MB into HDFS. So this 380 MB file will be broken down into 3 data blocks, where the first 2 data blocks will be of 128 MB, thus making 256 MB, and the last block will be occupying 380 minus 256 MB, that is equal to 124 MB. Then finally, these data blocks will be distributed across the cluster, that is in different data nodes. Now, when you will look at this implementation, you will find one more problem. What will happen if one of the data nodes containing the data blocks crashes? So how will name node ensure, or how will HDFS ensure fault tolerance with respect to the current implementation that we are having? Let's understand this problem with an example. So we'll take the same example that we were having in the previous case, where we are having one file of 380 MB that has been distributed across the HDFS with 3 blocks. Now let's say the third data node having the 124 MB block has been crashed. So in this case, we will not be able to retrieve the data, or we will be facing data loss issue. So HDFS has a solution for it called as replication factor. So what happens is, whenever you are storing any data or copying any file into HDFS, it is broken down into blocks, and each blocks are replicated thrice by default and are distributed across the data nodes. In case if any of the data nodes fails, in that case, we can again retrieve the data by having a replica that will be stored in some other data nodes. So that is how your HDFS ensures fault tolerance capability. Also, there is one more advantage of having master slave topology is that we can go ahead and add more nodes on the fly. So for example, let's say I want more disk space in my cluster. In that case, what I can do, I can commission new data nodes on the fly without affecting the current infrastructure. So enough of the theory, guys. So let's go ahead and have a look at the real cluster. How does it look like? And what are the different ways via which we can go ahead and access HDFS? So with Edureka's Hadoop certification course, you get the cloud access, where we are giving a real production cluster where you will be executing all the demos and you will be practicing all the assignments. So let us look at the name node web UI first. So basically, name node web UI provides you all the information regarding name node and HDFS. So here you can get information like the total configured capacity, the DFS used, the non-DFS used, block pool used, all those information are given here. You can also find information about data nodes. For example, in our case, we are having 3 data nodes, and all this cluster has been set up using AWS. So these are the hosts on which data nodes are running. Now let us see how we can access cluster or HDFS. So basically for that, we have something called as edge node. Edge node is nothing but an interface using which you can access the cluster, because in a production environment, you will be never allowed to access the cluster via one of the data nodes or one of the nodes that is there inside the cluster because of some security concern or if anything goes wrong. In that case, what we have a gateway node that allows you to access the entire cluster. That is called as edge node. So let us go ahead and have a look at that. So these are edge node, guys. Let me log in. All right. So basically, we'll be having 2 types of file system over here. One will be the local file system with respect to your edge node, where all the files will be there. And then there will be distributed file system with respect to HDFS. So let me list all the files and directory in both the cases. For example, for local file system, I will be using local shell command, which is ls, and using that, you can see these are the files that is there inside my edge node. Now for listing out the directories and the files that is there inside my HDFS, I will be using HDFS shell command. So for that, you have to go ahead with HDFS DFS, then -ls, and then you provide the name of the directory on which you want to list the files or subdirectories. For example, in my case, I'll be looking at my profile directory, that is /user/edu_big-data user. So as you can see, these are the files and directories inside my profile directory. So now you would be understanding how HDFS provides you that abstraction that you are using a single big machine. So let's go ahead and do some demos as well. For example, let's say I want to create a directory inside my DFS. So for that, I'm going to go ahead and say HDFS DFS -make_dir, and we'll go ahead with the name of the directory, which will be user/edu-big-data user. And let's name the directory as HDFS dir. All right, so the directory has been created. Let's go ahead and list all the files that is there inside HDFS again. For that, again, I'm going to go ahead and say /user/edu-big-data/user. Oops, I made a mistake, sorry. So here you can see I'm having a subdirectory called as HDFS dir, which has been created recently. All right. Now let's go ahead and copy some of the data from edge node to HDFS. So if I do ls, these are the files that is there inside my edge node. Let me choose one file. So basically I'll be copying this particular tar file. So let me check the size of this tar file. All right. The file size is of 1.1 GB. Let's go ahead and copy it into the cluster. So I'll say HDFS DFS hyphen put. Put is for moving data from your local system to HDFS. And then I'll mention the name of the file, which is cdh hyphen char dot tar dot gz. And then I'll mention the directory where I want to copy it inside HDFS. So which will be /user /edu big data user /sdfs underscore dir, the directory that we have created recently. Now let's go ahead and list the files that is there inside the newly created directory so as to ensure whether the copy has been done successfully or not. For that, I'm going to again do sdfs dfs -ls. Then we'll mention the directory path. So let me copy it and paste it over here. So as you can see, found one item. That is the file that we have copied recently. Now let us go ahead and check the number of blocks that has been made with respect to this particular file that we have copied inside SDFS. So I'm going to say Hadoop fsck, and then again I'm going to mention the directory path. So as you can see, we have total of 9 blocks that has been created with respect to 1.1 GB file, and each block has been replicated thrice by default. So in total of there will be 27 blocks there residing in SDFS in different data nodes. So this is how your SDFS works, guys. Now for a programmer, again, I don't have to worry about how data blocks are being created or how it is being distributed among different nodes. All I have to worry about is the logic that I'll be working on these data. So that's why your SDFS provides you all those abstraction and provides you tools and all those APIs so that it is very easier for you to go ahead and access it and manage the data that is there inside SDFS. With the given fact that even if I run a job or even if I process the data, that again the data will be processed locally in each node in a distributed and parallel fashion. Thus we'll be getting a reduced processing time. So whenever you're talking about huge amount of data sets or huge data sets, SDFS is the best option. The last fact that I'm going to mention is that all these SDFS hardwares are commodity hardware. So basically Hadoop is a very cost-effective solution to big data problem. In case if you have a specific use case that requires more cluster configuration, then you can go ahead and upgrade your cluster or hardware on the fly. You can add more nodes to it so that more parallelism can happen and you can again process a large data sets. All right, guys, so I guess you have understood what is SDFS and how does it work, what are the different shell commands that SDFS offers so as to access it or so as to manage or manipulate the data that is there inside SDFS. What is the function of name node? So basically whenever you are reading or listing the file, name node behind the scene is using his metadata information so as to locate all the data blocks and finally provide you the file that you were talking about. All right. So I hope you have enjoyed the video. In case of any doubts or queries, you can go ahead and mention those queries in the comment section below. See you in the next video. Till then, have fun. Bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!